Hi folks, Dr. P here. This is assignment question number 33 from the Rational Expressions and Equations unit. Aerion Airlines has a fleet of airplanes whose average speed is 4 times the average speed of the derailer passenger train. A derailer train requires 12 hours more than an Aerion airplane to travel a distance of 2,000 kilometers. Use the above information to complete the first 2 columns in the table. So we're going to summarize the information that's given to us here. For the distance for the 2 airlines, well, they both travel 2,000 kilometers. So it's going to be the same. For the speed, we are introducing a variable here called s, which represents the average speed of the train. The question tells us that the airplane's average speed is 4 times the average speed of the derailer train. That means that the average speed of airline is going to be 4s. In B, use the formula for time to write expressions in the 3rd column of the table. So this is an example of a problem that involves speed, distance, and time. So it's a speed, distance, time problem. And there is a formula that relates the speed, the distance traveled, and the time it took. Now, you don't necessarily need to memorize that formula. It's a very easy formula to derive from scratch. Let's introduce some variables here. So we already have the variable s for speed. We're going to call distance d. We're going to call time t. Now, we all know that when you're driving in a car, your speed is measured in kilometers per hour. So let's just replace the speed, the kilometers, which is the distance, and the time, the hours here, with these variables. So instead of speed, we're going to say s. The distance, this is the distance, the kilometers, we're going to call that d, divided by hours, that's going to be time, so divided by t. So this is the speed, distance, time formula. Now, what we want to do here is we want to express this in terms of t, in terms of time. So we want to rearrange this formula in such a way that we have t isolated on its own on the left-hand side. So let's first rewrite this like this. Speed equals distance divided by time. Now, the first step here is going to be to multiply both sides by time. When we do that, time is cancelled on the right-hand side. And we get, on the left-hand side, we get time times speed. On the right-hand side, we have distance. Now we divide both sides by speed. And the speed will cancel on the left-hand side. And we're now left with time equals distance divided by speed. So this is the version of the speed, distance, time formula that we need. And now what we want to do is we want to express the time for the airline and the time for the train using this formula. D, well, the distance is 2,000 kilometers. We know that. So we can write 2,000 in the numerator. The speed for the airline is 4s. For the train, the distance is the same. It's 2,000 kilometers. And for the train, the speed is s. Okay? So that's B. In C, write an equation using the expressions in the 3rd column that shows that the time difference is 12 hours. Okay? So we want to be a little bit careful here. So we know that the airplane is traveling faster, 4 times as fast as the train, which means that the time for the airline will be smaller than for the train. Or you can also put it the other way around. It's going to take longer for the train to travel the same distance than it's going to take for the airline. Okay? When they're telling us that the time difference between these two modes of transportation is 12. 12 is a positive number. That means that when we subtract these times, we need to subtract the smaller number from the larger number. Okay? So what we're going to do here, so the time, the larger time is going to be the train. This is the one that will take longer to travel that distance. So we're going to write 2,000 divided by S. We're going to subtract the time for the airline. So this is going to have a smaller value because it's traveling faster. And if we subtract those two quantities, we get 12 hours. Anytime you see the word difference, it means subtraction. In this question, you have to be careful what you subtract from what, okay? So you need to subtract it in this order in order to get a positive value here. In D, now we want to solve the equation in C to determine the average speed of each mode of transportation. Okay, so let's rewrite what we have. We have 2,000 divided by S minus 2,000 divided by 4S equals to 12. Anytime we're subtracting quotients, we need to have a lowest common denominator, which in this case is going to be 4S. Now, our goal here is to eliminate the variables, the S here and the S here, to eliminate those two variables in the denominator so that we can solve this 4S. The way we're going to do that is to multiply each term by 4S. We have 3 terms here. We have the 2,000 over S. The second term is the 2,000 over 4S. And the third term is on the right-hand side. It's just 12. So each term has to be multiplied by 4S. That's the first term times 4S. Second term times 4S. And then the third term, the one on the right-hand side, it's going to be 4S times 12. And now we can see that this S over here will cancel this S over here. This 4S cancels against this 4S. So now what are we left with? Well, 4 times 2,000. So the first term turns into 8,000. The second term is just going to be 2,000. That's all that's left there. And 4S times 12 is 48S. We can subtract 8,000 minus 2,000. That's 6,000. And then we divide both sides by 48. So S equals 6,000 divided by 48. And if we do that division, we're going to get that S equals 125. So this means that the train travels 125 kilometers per hour. The airplane travels 4 times that fast. So 4 times 125 is 500 kilometers per hour.